Hey Fix and Cruise family, and welcome back. Ever wondered what makes your car's engine breathe right and ensures it's getting the perfect mix of air and fuel? Today, we're diving into a small but mighty component, the Manifold Absolute Pressure, or MAP, sensor. This little guy plays a huge role in your engine's performance, measuring the pressure inside your intake manifold and sending that vital information to your car's brain, the Engine Control Module, or ECM. When the MAP sensor isn't working correctly, it can throw your entire engine system out of whack, leading to all sorts of frustrating issues, from sluggish acceleration to poor fuel economy. But here's the kicker. Sometimes, the problem isn't even the sensor itself. We'll explore its function, pinpoint its typical location, and walk through the common symptoms of a faulty sensor. Plus, I'll share a crucial tip that could save you a lot of time and money on diagnostics. Stick around, because you won't want to miss this. Sit back and take a watch.
The Manifold Absolute Pressure sensor measures that pressure inside of the intake manifold and sends that information to the ECM. The ECM uses this data to calculate engine load, adjust air-fuel ratio, and ignition timing. Your vehicle might not even have this sensor. It may use a mass airflow sensor instead. Some vehicles even use both. So before diagnosing anything, check your setup to see if your vehicle actually has a MAP sensor. The MAP sensor is usually located on the intake manifold. Here's the location on my Ford Fusion. The first symptom of a bad MAP sensor is poor acceleration. If the sensor is giving inaccurate readings, the ECM can't adjust fuel delivery properly. This can make the engine feel sluggish or hesitate when you step on the gas. The second symptom is rough idling or stalling. Incorrect pressure readings can cause the ECM to inject too much or too little fuel at idle. This can lead to the engine shaking, surging, or stalling when stopped. The third symptom is black smoke coming from the exhaust. If the MAP sensor falsely reads low pressure or high vacuum, the ECM may dump extra fuel into the engine, creating a false rich condition. This creates black smoke coming out of the exhaust. The fourth symptom is poor fuel economy. If the ECM is constantly adjusting for incorrect sensor data, the engine may run rich more often than it should, wasting more fuel over time. The fifth symptom is hard starting or no start. If the sensor fails completely, the ECM won't be able to calculate how much fuel the engine needs to start, leading to long cranks or the engine not starting at all. The sixth symptom is the check engine light turning on. When the MAP sensor fails, the ECM could detect the issue and set a check engine light. Here's some codes that can pop up. It's also important to know that the MAP sensor could still be faulty and not trigger any codes right away. So don't always rely on the check engine light to tell you something's wrong. Now if you have a scan tool that shows live data, you can test the MAP sensor by monitoring its readings at idle and while revving the engine. The numbers should change smoothly. If the values are stuck, jump around, or don't respond when you press the gas, that could be a sign the sensor's bad. Now here's something important to know. If your throttle body is dirty, it can sometimes trigger the MAP sensor code even when the sensor itself is good. I've had this personally happen to me, so before replacing anything, give the throttle body a good cleaning. Now if you want to learn how to clean the throttle body, watch this video next.
Alright, so as we just saw, the MAP sensor is definitely a critical component in modern engines. Its primary job is to measure the absolute pressure within the intake manifold, essentially telling the ECM how much air is entering the engine. This data is then used by the ECM to precisely calculate engine load, adjust the air-fuel ratio for optimal combustion, and even fine-tune ignition timing. Without accurate readings from the MAP sensor, your engine simply can't run efficiently, if it runs at all. The video highlighted some key symptoms that point towards a failing MAP sensor. We learned that poor acceleration and a sluggish engine response are common indicators because the ECM can't properly adjust fuel delivery. Rough idling or stalling can also occur when the sensor provides incorrect pressure readings, causing the engine to shake or surge, especially at a standstill. Another clear sign, and one you definitely don't want to see, is black smoke coming from your exhaust. This happens when the ECM, thinking there's low pressure or high vacuum, dumps too much fuel into the engine, creating an overly rich condition. Beyond these performance issues, poor fuel economy is a direct consequence of the engine constantly running rich due to inaccurate sensor data. wasting fuel over time. In severe cases, a completely failed MAP sensor can lead to hard starting or even a no-start condition, as the ECM has no way to determine the correct amount of fuel needed for ignition. And, of course, the ever-present check engine light will often illuminate, usually accompanied by specific diagnostic trouble codes, like P0105 through P0109, which directly relate to MAP sensor issues. The video also showed us how a scan tool can be invaluable for monitoring live data to see if the sensor's readings are changing smoothly as the engine revs, or if they're stuck or erratic, indicating a problem. Now for my critical take, and this is where we can potentially save ourselves some headaches and money. The video touched on a very important point at the end. A dirty throttle body can sometimes trigger MAP sensor codes, even when the sensor itself is perfectly fine. This is a classic example of how one seemingly minor issue can create symptoms that mimic a completely different problem. Carbon buildup on the throttle plate can restrict airflow, causing the engine to struggle, which then impacts the manifold pressure readings, fooling the ECM into thinking there's a MAP sensor issue. So, before you rush out to buy a new MAP sensor, give that throttle body a good cleaning. It's a much cheaper and simpler fix that could resolve your problem instantly. Furthermore, while the scan tool test shown is a great starting point for truly precise diagnostics, it's beneficial to compare your live MAP sensor data to your vehicle's specific manufacturer's specifications for idle and varying RPMs. Generic smooth changes are good, but knowing the exact expected pressure range provides a more definitive answer. Also, don't overlook other common culprits that can affect manifold pressure, such as vacuum leaks. A small, undetected vacuum leak in a hose or a deteriorated gasket can significantly impact the pressure readings, leading to symptoms similar to a faulty MAP sensor. Always perform a thorough visual inspection of all vacuum lines and connections. And finally, remember that wiring issues are common. Even if the sensor is good, a corroded connector or a damaged wire in the harness can interrupt the signal to the ECM. So, check those connections. It's all about systematic elimination and not jumping to the most expensive conclusion first. So, there you have it. Everything you need to know about the MAP sensor, its role, signs of trouble, and crucial diagnostic tips. Remember, careful diagnosis is key to avoiding unnecessary repairs. If you're looking for a good, low-cost scan tool, I've linked the one I use in the description below, along with a link to a detailed video on how to properly clean your throttle body. It's always best to start with the simplest and most cost-effective solutions first. If you found this video helpful, please hit that like button, subscribe to Fix and Cruise for more automotive insights, and let me know in the comments if you've ever had a run-in with a faulty MAP sensor or a tricky throttle body. Your experiences help all of us learn. Thanks for watching, and I'll see you in the next one.